So in this problem, we need to determine the equation of an ellipse whose focus is at the point 1, 1, with directrix given by 2x minus y plus 3 equals to 0 and eccentricity equals to 1/3. Let's begin. So we'll consider a vertical straight line which will represent the directrix of the ellipse. Its equation is given. We have 2x minus y plus 3 equals to 0. We'll consider a line that is perpendicular to the directrix line, and that line is referred to as the axis of the ellipse, with the condition that the focus must lie on the ellipse. The coordinates of the focus are also given, so that's 1, 1. Now, to find out the equation of the ellipse, we're going to consider a point P on the plane containing the directrix and the focus. Now, P has the coordinates x, y. P is the locus of the ellipse and its position is very important. It is chosen in the way such that if we take the ratio of the length PF to that of the perpendicular length PM, then this ratio is always a constant, and the constant is referred to as the eccentricity of the ellipse. That's given here that the eccentricity is 1/3. The eccentricity of an ellipse is always less than 1. So what we'll do, we'll use the condition that 3 times PF equals to PM to derive the equation of the ellipse. Now let's begin. So PF is the distance between the point P and F. So what we can do, we can use the distance formula to obtain the length PF. All we have to do is take the square root. Underneath the square root, we'll have to take the difference of the x coordinate and then add it with the square of the difference of the y coordinate. So that's y minus 1 whole square. Difference of the x coordinate will be x minus 1. This will be equals to, now we have to find out the perpendicular length PM. That means perpendicular distance of point P from the directrix line. There is a specific formula that we'll be using here. So here we have a point P with the coordinates x1, y1. And we have a straight line with the equation ax plus by plus c equals to 0. If we drop a perpendicular from point P on the straight line, meeting it at M, then the perpendicular distance PM will be given by the absolute value of ax1 plus by1 plus c divided by the square root of the sum of the squares of the coefficient of x and y. Now, we will have the absolute value. Then we'll take a ratio. We'll start with the numerator part. So here we'll have to take the coefficient of x, that's 2. 2 will get multiplied to the x coordinate of point P to give us 2x. Then we have coefficient of y, which is -1. -1 gets multiplied to the y coordinate of point P to give us -y. And then to it, we are going to add the constant term, that's +3, divided by the square root of the sum of the squares of the coefficient of x and y. So those are 2 and -1. So that means we have 2 squared plus -1 squared. Fine. Now, to simplify this, we're going to square both sides to get 9 multiplied to x minus 1 whole squared plus y minus 1 whole squared. This will be equals to 2x minus y plus 3 whole squared divided by 5. Now, when we further simplify this, we're going to get the equation 41x squared added to 44y squared plus 4 times xy minus 102x minus 84y plus 81 equals to 0. And this is going to be the required equation of the ellipse. Equation of the ellipse whose coordinates of the focus are 1, 1, with the equation of the directrix given and the eccentricity of 1/3.